Okay, so we don't have a whole lot of slides left. We're kind of at the end here. I do have one thing I did want to show you though. After we kind of go through this was a paper on some drone applications. But first, let's talk about forensics. Now, uh, forensic analyses are usually only necessary when we've got a delay or a claim or a dispute or something like that, or a question that's about what's actually happened, and we have to do a little bit of digging, figure things out. Um, Now, when it comes to being able to to be well prepared, if you do go into a claim or a dispute or something like that, you really have to make sure you've done you satisfied what you've got to do in the contract. You've got good documentation. You're able to have done a decent job of administering the contract, administering the project, and you're able to access the data and the reports and the photographs and you name it, right, of anything that you need to be able to go in and be well prepared. So forensic analysis can be conducted for all sorts of things. Usually we're looking at probably some kind of delay or maybe a budget bust or something like that. Looking at critical path impacts, right? Kind of the rule being that if you've got a delay but it doesn't hit critical activity, then we're talking about float. We're not talking about a time extension. Things like uh, taking account for adverse weather or abnormally adverse weather. Dealing with escalation or trying to determine whether or not we've had acceleration in a project. Be that directed or implied. We can also look at things like quality issues, right? Workmanship, design failures, you name it. Pretty much anything in dispute. And forensics, if you do any digging around on the internet, the stuff you'll pick up looking for forensics really it's like police work. But the majority of the forensic work that's out there, in our job, is really not. It's not like doing police work. It's a lot more straightforward in some ways. But at the same time, though, looking at and having to analyze a lot of documents or data, having to go through and forensically reconstruct a project schedule on a large project can be challenging. It can take a lot of time. And you want to make sure you do it right, right? Because if you end up in arbitration or mediation or, God forbid, in litigation, right, you want to make sure that when you walk in, your case is not going to get any holes poked in it, right? Because you didn't do something right, or you missed something, or you did it wrong, or you made the wrong assumption, or they can show that they're assassinate your position, right, because of something you did or didn't do. So it's I actually really enjoy doing this work. I think it's really fascinating. But then again, it takes a lot of time, and you want to make sure that you've done your due diligence, you've done your homework, and you're able to tell the story, and be able to, hopefully be able to go back to the negotiating table, right, and be able to resolve things and get your project back going again. But that being said, deep learning applications have been developed and used for forensics. I don't really believe that their full potential is even close to being realized, as well as other applications we haven't considered yet for machine learning or deep learning algorithms. But I'll show you some stuff that's been done here that's actually a few years old. So I got a colleague of mine. I mentioned him earlier, Dr. David Jong. He's at Texas A&M. Used to teach at Iowa State. He's a Purdue guy. Really, really sharp. Had a lab up there that was on design, or is on data analytics, right? And did quite a bit of research and developing an automated forensic schedule assembler, right? And different applications for using daily work reports. Anytime you have like a lot of data, you have a lot of reports or stuff like that that's generated, data that's generated by the project, you have an opportunity to be able to use them for other things, right? So anytime that I'm generating a lot of information, or I'm generating knowledge, or I'm generating reports or records or documents, there's always an opportunity now with machine learning applications to be able to use those to be able to understand a project, understand things, and to glean trends and underlying trends maybe that we didn't see, or to understand how things worked and provide context. So daily work reports are an excellent source of actual project data. As opposed to like looking at procurements, like public procurements that are published. If I got bid tabs, those are at the start of a project. Those are costs for work and quantities of work before I've done any actual work, right? Those are an estimate, essentially. Daily work reports have actuals in them. So how long did it actually take? What work actually got done? How long did it actually take to do the work? When did it happen? All that kind of stuff, right? So, your DOTs usually have got some kind of digitized daily work report requirement. And I don't know any DOTs that don't. There may be some out there that don't. But being able to have those generated and stored in a single single repository or in the cloud means that they're accessible, and we can look at them. And we may not look at them unless we're doing like payment processing, or we get to a dispute. When we're looking at this assembler for putting together an as-built schedule for when you have a delay claim or something like that on a project, it's got great data to be able to do that with. So you've got activity data, which is where's it at, right? We got locational information. We got the type of work that's being done as far as classifications, maybe pay items, work quantities, who the contractors or subs are that are on the site. You got equipment information typically as well. So what are the types and the quantities, the counts of the equipment that's out there? What are the hours, right? How many hours have we been running? Same thing with labor, right? What different types of labor classifications, especially if you're on like a Davis-Bacon project, right? And we're keeping track of payroll and that sort of thing. We're gonna have a lot more granularity when it comes to those. And then also with materials, right? And this is always a big one, is tracking materials. What are the types of materials that were being either received, delivered, created, installed, stored, moved on that day, right? How many were used? How many are still stored? And being able to pull that data. So I've done this more than one time myself. But assembling an as-built schedule is tedious. It takes time. You have to be real careful. You got to double check your what you're doing, and when you manually construct them, it just takes a lot of time. And you got to make sure that you've not made any logical errors. You got to check all your activities. You got to check all of your durations. You got to check all that stuff and be able to document it, right? And back up those documentations. So being able to automate some of this stuff can really improve, can really give you more time to do the analysis, right? And look at causation and those sorts of things. So first one here that you see is, this actually comes from one of the initial model. It was put together around 2015 or so. One of Dr. Zhang's grad students up there is actually a pretty well published researcher now, Joseph Shrestha. But he put together a model that would that used a machine learning algorithm to extract data out of the daily work reports and pre-process it. So essentially organize it, classify it, right? Get it into a form that can be used. So it identifies what it is, organizes it, and then associates the data that's in those daily work reports with the schedule activities. So to then make that connection. Okay, here's the activity, here's the work, there they go, right? And then data mining is the second algorithm. It takes and converts that raw data into schedule activities in a tabular format, right? Extrapolates them, extrapolates those start and finish dates, right? Because that's what we're looking for. Hey, here's the activity, here's the work, here's when it actually started, here's when it finished, right? And this is tying those little nodes together, saying, okay, hey, this was, yes, go ahead. Yeah, it just has to be modified to work with that software. Yeah, yeah. I mean, it takes some work to adapt it, but I mean, it's essentially the same thing. You know, I mean, the big challenge, only challenge you really have when you're trying to use this for like a different platform is like the paths. What's the path that I'm going to be able to pull data from? And then also, is there any difference in how that data is organized, right? So I may need to go and do, have an initial algorithm to train. I may need to retrain that machine learning algorithm based upon how data and site managers kept, right? Be able to pull that out. So, but that's essentially. I mean, it's the tough part is already done, really. So. Yeah, you'd have to get a hold of him, but I can get you in touch with him if you'd like. Yeah. They actually did some research as well. Put one of these together for Montana DOT that was federally funded, so you might be able to get hands on that. But yeah, no, great little deal. But so then that's kind of the piece though, is that data mining there is extrapolating those start and finish dates, because what it does is it says, okay, my algorithm is going to look through and it's going to look at all the activities. Here's what we're doing, right? Here's what this equipment and this kind of work is associated with this activity on the schedule, right? So then all I'm doing is looking at when was I working on that, right? And okay, I was working on this date. Okay, that's the earliest date that I find anything related to it. That's the start date, right? And essentially it does the same thing until it gets the finish date. So what's the last one that's associated with that? There you go, right? Or if your daily work reports have the actual schedule or activities on there, that makes it a lot easier, right, to pull those out. Did you have a question? Okay, sorry. I just want to make sure I'm not missing anybody, because I'll get going here. Y'all know you've been here all day listening to me. So, but yeah, so the data mining is that's that kind of like nuts and bolts piece where it's like, okay, what does this mean, right? How do I take and apply this information? So then it pulls that out, and then you've got that step that's that human interaction, right? Where I'm going to look at, I'm going to inspect it. I'm going to say, okay, does this all make sense? And I want to review it and make sure it does, right? Because maybe it misinterpreted a piece of equipment, right? Or maybe there's a piece of equipment that I've got on more than one activity that it tried to tie those two together, but it wasn't, right? So you always have to have a step in a manual or ability to go in there manually and do your QC over what the machine assembled, right? And go and just make sure, okay, does the logic still hold up, right? So. And then it builds that into just a real straightforward schedule. So this is kind of that, looking at that process as kind of how it lays out, and up here you had the daily work report data, where you've got a whole bunch of stuff in here, and you probably don't need all of it, right? I just need some of it. So it's identifying the things that are needed, and then it's pulling those out, extracting those. Real simple, a little bit of code here to do your data selection and pre-processing, right? Sorting through what they are and then getting it ready to data mine, right? And then once I've mined that data, have it assemble everything in that tabular format, right? So now I've gone and I've gone and I've extracted the data, I've processed it, I've categorized it, I've associated those things with the actual tasks. I've got maybe a pay item number on there or a unique ID, and I'm building out that schedule for it. So, and then that last piece is really just the interpretation and evaluation. But really, the amount of time this saves is incredible. So being able to take and in a very short amount of time to generate an as-built of what actually happened, this is, I had a client that I did one of these for 2 years ago, and it took me probably a full week to reconstruct the schedule manually on a project they had a claim on, right? And I could probably do this if I had used this one, or if I had access to this code or the data, I could have done this in an afternoon instead, right? So, you look at just the time savings. It gives you more time to do analysis. It gives you the opportunity to be able to to be able to talk about it, maybe dig in a little deeper, and get more prepared, right? To really have good understanding. So, any questions about this other than you want it? Right? There's actually several related papers out on this as well. There's probably 6 or 7 of them out there that are related to other applications. One of the ones that's really interesting, I think, is looking at using this same model to be able to forecast the likely schedule duration of a project that's a new project, because it's just another step, right? So if I've pulled daily work report data and I got it associated with projects and I've got as-built schedules that I can automate, I can see what actual production times look like, actual rates. And if I'm looking at, using, maybe a case-based reason algorithm to identify highly similar projects, and I'm planning it, I could use this as an ensemble as well to go in with my estimator and be able to say, okay, here's what the likely schedule duration should be on this project. And this is one that, if I had an idea of what the total scope of the project was, a narrative scope, I could identify more than likely what the likely selection of activities were going to be or pay items, and I could build a schedule based off of that, right? So like you look at, kind of how these tools can be applied, and nobody's doing that right now, integrating all of them together. But this is something I think that we're going to see, is these cross integrations, and ideally we'll probably find this stuff on single software solutions or stuff like that, right? Where we can integrate these things into our project management software. We can have them as additional tools that we keep on hand to be able to help improve our planning capabilities and management processes too. But yeah, so like that's another way to develop data or use data, analyze it, that's useful and applicable, right? So this was a new study that just came out. Just wanted to reference this. This one was really interesting to me because it was looking at predicting the cost impact of non-performance, like predictive, looking forward at it. And this model, it had a really robust model. It was probably had like good 8 layers, at least 4 or 5 different algorithms, machine learning algorithms built into it, multiple data processing steps and classification. And what's interesting about it is they used a random forest algorithm that was then reinforced with this gravitational search algorithm that was used to tweak this model to optimize the results. So random forest does a good job of being able to create predictive synthetic data, but a GSA algorithm takes, and a gravitational search algorithm actually takes, and it looks at specifically the interactions between the various different features, and it compares them to what the target is, what we're trying to estimate, and it tweaks those. It's called the hyperparameters. Tweaks those hyperparameters so that they're optimized to that specific prediction itself. So it can really help with building the accuracy. But this one was interesting because they used it to be able to look at, okay, if I'm working on a project, if I'm in a project, right, can I identify, based upon the data generated from that project management, whether or not I'm going to have quality issues? And what are the indicators that I may have quality issues? And what is the likely impact as far as cost if I do realize those, right? So this is like an early warning system essentially set up so that I can keep an eye on and keep track of the quality concerns of my project delivery, right? And so that's kind of what this piece here, and I included these because it was cool looking. It's a lot of colors, but they're called shapely additive explanations. So this whole model, pretty robust model, and it's almost like a black box in a lot of ways. And one of the ways that they use this to to interpret the outputs of this black box with these additive explanations. So, and pretty much what they do is each one of these values on the side here, these were the different types of quality issues that you could have, right? Based upon the different features of work. And then when you looked at these additive or these explanations, it shows whether they're going to impact, whether they have a high impact on the cost model, or a low impact, or where they land, right? So if you're looking at these and they're up here on the right, whatever these ones are, S2, S4, these have a really high impact, right? And so as far as features that are associated with them, if I understand certain features within a project are gonna have a outsized impact on cost performance, that lets me know that I have certain things that I'm gonna have to make sure that I spend more deliberate time managing, right? That I pay more attention on. You know, I mean, because I'm from the school of management that I like to apply the 80-20 rule, right? You know, where 20% of my pay items have 80% of my money, 20% of my project drives 80% of my cost. 80% is not going to affect anything unless I don't manage those, unless something comes up, right? Like, I don't care to be able to get the project done, right? I'm going to look at where the money's at in the project. I'm going to look at the things that drive the schedule, that drive the production, and those are the things I want to manage with malice and a forethought. And I'm going to manage everything else by exception. So this is one of those things. It's in a kind of an additional kind of tool. And this is a concept. You know, like I said, they just published the paper. It's brand new, so there's no actual direct application. But this is the kind of stuff that you'll see where, you know, it looks like really, you know, fancy, big, spoofy stuff. But what it ends up being is these really kind of very highly intelligent indicators. And, you know, being able to understand, gain better understanding of how our projects function, how, you know, what actually matters, how severe the impact things will be, just adds, gives us more ability to be able to be proactive as opposed to reactive, right? So I thought it was an interesting one. I want to share it. There's a link there. You can go find that in the through the DOI. But any questions on that? So, all right. Well, I did have. Let's see if I can pull this one up real quick. This will open on the right side. Let's see if this will do it for me. There we go. All right. Now let me dick around with the screen share here real quick, and just wanted to. Yeah, there we go. Oh shoot, this stupid thing! I tell you what. Okay. Okay, I'm going to change my share here. All right, so this was, I just wanted to show you guys this. There are some pretty cool graphics on this, but this paper, and if you'd like, I'm happy to send it to you, is a one that was looking at using drones to help for pavement quality, right? Looking at the temperature of hot mix asphalt, temperature segregation, and uses machine vision. But what's kind of interesting about this is if you look at you know, like some of the imagery. Let's see if this thing will zoom in here. There we go. Yeah, so looking at being able to take and use computer vision to do some pretty slick looking analysis of your payments, and then process these down and be able to extract some really interesting results on quality. So this is just a matter of training training a drone or training a algorithm to look at to count pixels essentially and associate them with the temperature, right? And be able to figure out if there's any kind of differentials in there, right? And what those happen to be, as a way to then measure quality, right? And keep track of how they perform. So this is it's kind of cool, but these are the kind of things that we'll see getting used these days, and we're going to continue to see them. So if you're in the inspection, engineering inspection, working as a GEC, this is the kind of stuff you should be looking at, right? You should be exploring is what sort of technology and tools are available to be able to help my staff be able to spread and cover more work, right? What are the things that I can do, that I can use, that are going to add more value to my clients, to the owner, right? And if I'm if I'm the owner, right, what are the things that I should be asking for, right? And being able to have some of this stuff that's so easily accessible, right? These are tools that no one has ever had before, and we got a lot of smart people out there who are working really hard and are figuring out some really cool stuff that all of us can use. So anyways, I just wanted to, that was one last thing I was gonna show there. I thought that was kind of interesting. But anyhow, so why is this not working for me now? There we go. So that's the end of my presentation today. I'm going to hang around here for a while. I want to thank everyone for online for tuning in. I want to thank everybody who came up here to do this in person. I hope this was interesting. It was at least some interesting PDHs. Make sure you signed in, and we'll Dr. Molina there will make sure you gals get your PDHs. I did want to include the contact information for the Southern Plains Transportation Center. I want to thank them for the opportunity to teach this kind of course. This is they're the UTC for Region 5, and have a lot of assets and a lot of potential here. So if you haven't done anything with SPTC before, as your first time, look forward to seeing you again. There's more information there at their website. If I can ever be of assistance, please feel free to reach out, let me know. Otherwise, have a nice afternoon.